Okay, so the next algorithm that we are going to look at is the sorting algorithms. The problem is basically to arrange a list in an ascending or a descending order. So for example, we have this list over here. It's unsorted, it's not in any particular order. If we sort it, we can write it in ascending order like this. And we're going to assume that we're trying to do just the ascending order, but the idea is almost exactly the same if you want to do it for descending order, right? And similarly, you can have an alphabetical list which you want to turn into alphabetical ordering, and both of these require some sort of sorting algorithm. Again, the idea is how do we write down an algorithm that would allow a computer to perform this task for us. So the first algorithm is the bubble sort algorithm. The idea behind this is that you perform n-1 passes over your list, where n is the number of elements in your list. So in this list you have 6 elements, so you will perform 5 passes. And each pass will look something like this. You start off by pairing the first 2 elements and comparing them. And you see if they're in the correct order or not. If they're not in the correct order, then you interchange them. So 2 goes here and 7 goes here. And so to continue the first pass, you then move on to the next 2 elements. We now compare 7 and 1. They're also not in the right order. You shift them, 1 goes here, 7 goes here. Same idea here, same idea here, same idea here. Over here, of course, you don't perform any interchange because 7 and 9 are in the correct order. And that completes from here till here. This is your first pass. And the idea is that if you perform n-1, which is 5 passes in this list exactly the way that I performed this first pass, your list will be completely sorted. It's possible that you don't need 5 passes, you may need 4 or 3 or even less number of passes, but at maximum you would need n-1 passes. So the next pass then starts. Again, compare these 2 elements, not in the right order, we interchange them. Then we compare these 2, they're in the right order. Then these 2, correct order, these 2, correct order. And then we stop here. So the first pass went up till this element. The second pass will go up until this element. You don't have to check this element in the second pass because you've already checked whether the order was correct or not. So in the first pass, you will check the last 2 elements. But in the second pass, which was basically this one, second pass, you don't need to check these 2 elements because they've already been checked and they won't be changed. So you just check until this one and this completes your second pass. And the idea is if you complete 3, 4, 5 passes, your list will be completely sorted. Of course, this list did not require 3rd or 4th or 5th pass. It was already in sorted order, and hence the bubble sort algorithm has sorted your list. And the way we write this algorithm in pseudocode is as follows. Your inputs are n real numbers. You start off your first for loop, which basically tells the variable I to go from 1 to n-1, which basically, if you think about it, this is the ith pass. And then within each pass, so you will have another variable j which will go from 1 to n-I. So n-I for the first pass will basically be 6 minus 1. So the idea is in the ith pass, this was the ith pass, you will check up until this is j. You will check up until the jth element. This is the last element that will be checked. J goes from, sorry about that, j goes from 1 to n-I. And so that's your algorithm. What you do is you compare aj, the jth element in your list, and the j plus 1 elements in your list, and then you compare them. If the jth element is bigger, then you interchange these 2. Otherwise, you don't do anything. And so that was the idea. In this one, the jth element was bigger than the j plus 1 element, we interchange them. The jth element was bigger than the j plus 1 element, we interchange them. And once you complete all of these passes and all of these nested passes, you will see that your list will be sorted, and that's the bubble sort algorithm. That's of course not the only sorting algorithm. Another algorithm that we have is the insertion sort, which is much faster than the bubble sort, and it works like this. The idea is that you can first compare the first two elements, and the idea is you will consider that part of your list is already sorted. So let's say right now I'm saying just the first element is correctly sorted, but the second element needs to be inserted in this list in the correct place. So I check 2 and I see that 2 is smaller than 7, so I have to insert it over here. So I place 2 over here and 7 over here. Now this list, the list that is underlined with this over here, it's sorted right now. And now I have to insert 4 in the right order. So I check again where the right place for 4 would be in this sorted list. It's not in this place, it's in this place, so I insert 4 over here. 2, 4, 7, this is now sorted. Now I check my next element 1 and I insert it and I check where it will come. So I check whether 1 will be inserted here. Yes, because 1 is smaller than 2, I insert 1 here and I write down the rest of the list. Next element is 5. I check 5 won't be inserted here, it won't be inserted here, it won't be inserted here. It will be inserted here because it's bigger than 4 but smaller than 7. So I insert 5 here and this is my list now. And once I do it for all these elements, I insert them in the right place, I will have my completely sorted list. And if you think about it, it doesn't require more passes. Just one pass is enough as long as you ensure that you're inserting the elements in the right place, and you will have a sorted list. And the way you write this in an algorithmic form is as follows. You keep track of just one element j. J is the element that you're trying to insert. And you start off your I, where I checks, so j basically checks the element to be inserted. And I keeps track of the place where aj would be inserted. In the next video, I will be discussing this algorithm in more detail. And so let's just read this algorithm through. So the algorithm starts with this while loop. It checks aj is greater than ai. Until aj is greater than ai, I'm trying to basically find the place where this element would be inserted. So until aj is bigger than ai, I keep on increasing I until I find the right place. I keep on incrementing I. Once I find the right I where this element needs to be inserted, I set m equals aj. Basically, m is a temporary storage for my jth element. I use another list, another for loop, where k goes from 0 to j minus I minus 1. It won't be immediately clear what this is doing, but the idea is that this loop basically writes down the list up until the ith element. So it copies the correct list into the right place, and then basically we insert m, which was my aj element, and we insert it in the right place. I understand that this is a complicated code which won't be immediately clear to you, and so you can do two things. You can check out the next video where I go through this algorithm step by step, checking what the value of j is, what the value of I is, what m gets set, how the list changes with time. Or you can just take this algorithm and play with it on your own. Take up a list and try to sort it using this algorithm. Assume that you are the machine and follow these steps exactly like they're written. Keep track of j, keep track of I, keep track of m, keep track of k, and keep track of the list that you're sorting. And if you follow this algorithm step by step, you will notice that it does exactly the same thing as the insertion sort that we've done here. These, by the way, are not the only sorting algorithms. There are many sorting algorithms out there. Some are much faster than the others. Bubble sort is one of the slowest algorithms, but the idea is we should know about all of these, at least a couple of these sorting algorithms, so we can try to think about what makes one sorting algorithm better than the other sorting algorithm. So there's other sorting algorithms like, I'll just name a few, quicksort, which uses the idea of randomization. There's also merge sort, which uses an idea similar to binary search in that it breaks down your list and sorts one part at a time. And there's also selection sort. So many different kinds of sorting algorithms that you can check out. Perhaps you can Google and check out.